And we introduce the concept of the power of the lens, right? P is equal to 1 over F. Okay. And negative mean you have a concave lens. So concave lens always have a negative focal length, right? Concave lens. Positive mean you have a convex lens. Right? Good? Hello?
Got it.
Yes.
Now what I'm gonna do, I'm gonna show you how to do the problem with the drawing and the calculation. Now the equation will be the same. And no matter what type of lens we have, whether we have a concave lens or whether we have a convex lens, and in this case, we call them a thin lens equations. So the form is still the same. 1 over F is equal to 1 over dO plus 1 over di. And of course, dO and di will be the object distance or the image distance. Now I'm gonna do the concave lens first. No, I'm sorry, the convex lens first. Now the way we draw it, so I don't want to draw something like that. See, sometimes it's hard to make them symmetric. So what I'm gonna draw an arrow like this. Now if I draw an arrow like that, it means that I have what? I have a convex lens. Good? Hello?
Got it.
Now then I'm gonna use a ruler. I'm gonna draw the principal axis, right? Now then I am going to introduce my focal point. Let's say my focal point is 6 units from here. So that will be another 6 units for the C. Now I'm gonna put my image. So I'm gonna put it between C and F, right? Now, like I said, you're gonna have you should have 5 choice, right? Now then I'm gonna build with now whatever for the lens, right? It's all about the intersections of the reflecting intersection of the not reflect, right now a reflected rays. Okay. Now I'm gonna draw the incident light, right? Like this, right? Hello? Hello?
Yep.
Now, for the lens, right? We don't use the focal point on the left side. Remember that they reflect, right? So we're gonna use the focal point on the right side. Let me draw this. Now I'm gonna erase this. 6 unit, right? So I'm gonna use the black. Okay, 1, 2, 3, 4, 5, 6 here. So 1, 2, 3. Right? Hello?
Okay.
Now for the lens, if you're talking about a focal point or your center of curvature at the same side of the object, they are negative. And the focal length and the center of curvature on the other side of the object will be positive. So like I said, it's all about the reflect, right? Keep this work in mind for the lens. So then I'm going to, now remember that they're gonna reflect, right? Reflect what? I have a convergent lens, right? Remember the convex lens? Hello?
Yes.
So therefore, the beam is gonna pass through the focal point here. Now I'm going to put the dashed line. To just emphasize that they are the reflecting waves. Okay. Now, then what is the second way you can draw, right? The second way you can draw is you treat the vertex right now. The vertex just like a plane lens. When the wave passing through, and they're not gonna reflect at all, right? They just go straight. So what I'm saying, they're gonna go straight like here. Good. Hello?
Good.
Now, so therefore, what should I say that? And another way to draw that is the beam passing through the focal point and the same size of object, like this. Now, write this here, right? So I'm gonna draw that. Oops. Passing through the object, the focal point, right? Hit here, and then what happened? Hit the lens, right? They're gonna parallel out. Now, what happened? You see that? So where's the location of the image? Hello? Where's the location of the image?
To the right.
It's gonna be the intersection, right? Remember the key word here is the intersection and of the reflecting wave, right? Intersection of the reflecting wave, right? So it's gonna be here. Good. Hello.
Got it.
Now, then again, you're gonna tell me the characteristic of the image, right? So this image is real or virtual? This image is real. Why is real? Why for the lens is exactly opposite to the mirror, right? Remember that mirror, you form the image, real image, when the location of the image the same side of the object, right?
Yes.
But for the lens, that will be exactly opposite, right? The lens is gonna form a real image when the image is in the opposite side of the object. Is that right? Hello?
Yes.
Now, this image is smaller or larger, right? It look like, I don't know, we can do a calculation, right? So I would say that they're smaller. So we're gonna calculate that to verify that. And this image, I'm gonna put a mark, now this image is what? Inverted, right? It's not erect, it's inverted, right? Good. Hello?
Yes.
Now I'm gonna do the calculation on that, right? Remember I have 6 unit and a focal point and 6 unit on that 12 unit here, right? This look like 6 plus I would say the 6 plus 3, right? Okay, let's say the DO is 9 centimeter. Yeah. Am I right? Hello?
Mm-hmm.
Yes.
Now remember that I have a convex lens. I'm using the focal point on the opposite side of the image, the opposite side of the object, right? So this one I guarantee is positive. Right? Now, so therefore, what is the now let's say the height, right? Object height. Object height, let's say is 6. I'm gonna say the 2 centimeter. Right? It's actually less than 2 centimeter, right? So I'm gonna say 1.5 centimeter. Now, really doesn't matter, right? Really doesn't matter. So let's say 2 centimeters. So therefore, what is the inmate distance, right? Will be 1 over f minus 1 over do, right? Am I right? Hello?
Yes.
Now, so therefore, what do I get? Now I will get 1 over 6 minus 1 over 9. So therefore, I have 36. 9 minus 6, right? Am I right? Hello? No, not 36, right? 54, right? Hello?
Yes.
That will be 3 over 54, right? But remember that I'm gonna flip them over, right? So therefore, the DI is 54 divided by 3, right? So what is 54 divided by 3? So I'm gonna calculate that. 54 divided by 3 is 18, right? 18 centimeter. So my question to you that this look like 18 centimeter? Quite, right? Like I said,
Yes.
that my drawing a little bit off. If you really want to draw a very good sketch, the graphical method, you need to have a very good ruler, right? Understand what I'm saying? Hello?
Yes.
Now, then once I know that my image is real at the opposite side of the object. Now, then I want to verify the size, right? So remember that the magnification, right? Is equal to minus, what is that? DI over DO, right? Is that right? Remember that? Hello? Right, DI over DO, right? Which is also equal to the image height divided by object height. Now, if they are bigger than 1, mean I had the image is larger than the object. If they are smaller than 1, mean the image is smaller than the object. Are you with me? Hello?
Yes.
Now then I'm gonna put it in, right? Minus DI minus 18 divided by minus 9, right? Am I right? Hello?
Yes.
That will be, what is this? Will be 2, right? And not minus 9, positive 9, right? Good. Now, what this negative sign here tell us? This negative sign tell me that they are upside down, right? Am I right? So if they are positive, mean the image and the object, they are in the same orientation. In this case, will be pointing up. If they are negative sign, mean that the object and the image is in the opposite orientation. Are you with me? Hello?
Yes.
Yes.
So therefore, this one is also equal to what? This one are also equal to image height divided by the object height, right? Will be 2. So actually, this should be 2 centimeter, right? Now, like I said, oh no, Dr. Chu, your drawing is exactly same. But like I said, that the drawing only give you an approximate idea, right? Unless that you have a very precise measurement. Are you with me?
Yeah.
Okay. Now what I'm gonna do, now one thing I know that magnified glass, right? What is a magnified glass? Magnified glass mean they convex lens, the convergent lens, right? just like the example I gave it before. Now then I'm gonna list all the givens. Now you got to make sure that how you interpret the given, right? Don't interpret it wrong, so everything will wrong. So F is what? The F is 15.8, right? Hello?
Yep.
Now then what else I have? Focal length, magnified Harriet, 18 point from the mole, right? So in other words, the DO is 11.8 centimeter. Am I right? Hello? Hello?
Mhm.
Now then, what is DI, right? So we can calculate that, the image distance, right? That's what the AS, right? 1 over F minus 1 over DO, right? So which is 1 over 15.8 minus 1 over 11.8, right? So what is this? That will be 1 over DO. DI, right? So I'm gonna, that will be 11.8 minus 15.8 divided by 15.8 times 11.8, right? Am I right? Hello?
Yes.
So the top will be minus 4, right? 11.8 minus 15.8 is minus 4. And the bottom, you multiply that by 15.8 times 11.8 is 186. 186.44, right? So therefore, my DI is divided by 4. 186.44 divided by 4 is going to be 46.61. Negative, right? Negative mean what? Hello? Negative mean what?
To the left.
The same side of the object, right? You're going to have a virtual image, right? Is that right?
Yeah.
Is that right? Negative mean you have a virtual image at the same side of the object, right?
Okay.
I'm gonna finish that first, then I am going to draw it again, right? Now M is equal to minus DI minus DO, which is also saying HI over HO, right? Now, what is DI? DI is minus 46.61, right? Am I right? Hello?
Yes.
And the DO is 11.8, right? So what is this? Divided by 11.8, so 3.95. So therefore, they are magnified by 4 times. Am I right? Hello? Now I'm gonna draw that for you, right? Now, the way I'm drawing, same thing. Now I'm gonna we just treat it like 16 and 12, okay? It doesn't matter, like I said, it's 16. Okay, 1, 2, 3, 10, 16, and 12. Okay, so I have that's 8, 10, 10. Okay, 16 is here. Right, and then 12 is okay, 6, then 12 is here. Are you with me? Hello?
Yes.
So here my focal point, right? So I remember that I don't use the I have to use the one on the right side, right? 16 will be A. Yeah, that's exactly right here. Right? A, okay, 4, 6, 8, yeah, 16 here. And 12 is here. Right? Hello? No, draw it wrong. Yeah, what I'm doing. This should be F, right? And that should be the location of the object. Right, am I right? Hello? Hello?
Yes.
Now then I'm gonna do the constructive reflecting wave, right? So parallel in, it's gonna hit the focal point on the other side. Right? Hello?
Yes.
Now then I'm gonna have the hit the vertex, right? Again. Then they're gonna pass straight through out, right? Right? Hello? Now, one thing I can tell that is this two reflecting wave, right? You see my cursor moving?
Yes.
These two reflecting wave, they never form an intersection, right? Then what we're gonna do? So we need to extend that back to the other end. Right here. What I'm saying is we need to extend this. And then I'm gonna pick my red again. Then we're gonna extend this back. Okay, so therefore, where's the location of the image? Hello? Where's the location of the image? It's gonna be here,
Left.
right? So the image, I'm not gonna use the solid line to draw that, right? It represents that my image is virtual, right? So again, virtual. Well, verify that by my calculation here, right? And then they are what? Enlarge, right? Hello? By how many times? Approximately 4 times, right? Remember that we calculated that, right? And then what else? The image is erected, right? Or the same orientation of the object. Am I right? Hello?
Yes.
Mhm.
So therefore, what is really tell you that, right? If you use a magnifying glass to magnify something, and you're gonna have the object distance has to be smaller than the focal length. Make sense? So if you want to magnify something, right, your object distance has to be what? Has to be smaller than the focal length. Am I right? Hello?
Yes.
Good. Now, then how are we gonna do that? we still do the same way, right? Now remember that if I have parallel line going in, and then what happened? They're gonna hit a focal point, right? Am I right? But at the same time, you're gonna hit the tips of the image, right? You understand what I'm saying? You're gonna hit the focal point.
Yep.
But you're gonna hit the tips of the image too at the same time. If you go back to see my drawing before. Now, why is that? Now, let me draw this line first. Right, am I right? Hello? Hello?
Yes.
Now, how I'm gonna verify that? No problem, I can verify that. Remember that if I had incident wave strike the vertex, right? They just go straight, right? The vertex behave like a plane lens. Am I right?
Mm-hmm.
Like this. This line just goes straight out, right? Am I right? Hello?
Yes.
Now, so therefore, where's my two focal point, right? My two focal point will be here. Whatever the beam, the first wave hitting the intersect with the, okay, let me zoom it in. Now, whatever the first wave hitting with the principal axis, that will be my focal point. Now here, see, here will be my focal. 1, 2, 3, 4, 4.5, right? Now this will be my focal point. Now my ruler here, I cannot draw anything. So here, right? Am I right? Hello?
Yes.
Yes.
The focal point right here, right? You got it? Right, now this type problem is more like a what? You can think about it more like a reverse engineer. I give you the result and I ask you find the cause, right? Something like that. Good?
Good.
Yes.
Nothing way, right? So my ruler here. This is all about object, right? Now then I have a parallel line in. Okay, hold on. My pen. Okay, here. Now it's gonna like I said, I'm gonna hit the focal point, right? So focal point in such a way what? And I know that all the way on the right side they're gonna diverge, right? So I know that I need to extend the reflecting wave backward, right? So it should be like this. Now let me draw it. Right? But I'm gonna extend it backward. Now you know what I mean, right? Am I right? Hello?
Yes.
Yes.
Now then the other way to verify that I can use the way hitting the vertex. Right? So I'm gonna use the way hitting the vertex. I want to verify that, right? The uniqueness of the focal point. Now, remember that if I pass through the vertex, they just behave like a plane mirror. Hello? Hello.
Oh, yeah.
So what I'm saying that lie right here. Now you see that they're uniquely intersect backward at this point. So therefore, I know that when I pick this point, my construction is correct. Right? Am I right? Hello?
Yes.
Mhm.
So therefore, they said two focal point, right? Should be this another symmetric point here. So it will be here, right? Approximately, right? Hello?
Yes.
Good.
Good.
All right. Now, what I'm gonna do next thing, now what is the divergent lens? As the name said, that the divergent lens, as the name said that they are diverse the reflecting wave. Right? So, or we call the concave lens. Good. Hello. Now, convergent lens or convex lens, it's just your reading glass or your parent reading glass. Divergent lens will be the lens you use for your near sight. Now we're gonna talk more detail on that in the next semester, next chapter. Right? Now, what does a divergent lens look like? Like this, right? Hello.
Yes.
Now this one we call it biconvex, right? Biconcave, I'm sorry. And then I will have something like this. And this one is called Pano concave. Well, what's called a Pano concave? One side is flat, one side is curved, right? Remember the property of divergent lens or the concave lens is the edge is thicker. The edge is thicker than the center, right? So if anyone wear the glass John, right? John, you wear the glass, John.
Yes, I do.
And if you have a very high prescription on your near side, right, you will see a lot of ring, right? Am I right, John?
Rings?
You see a lot of ring of your lens. You don't know what I'm talking about? Okay, let's use the ruler. Okay. You good? Hello?
Yes.
I am going to create my focal point. Right? Now, if I have a ruler here, it won't let me do that. Okay, it's okay. Now, I draw both of them. Now, what I'm gonna do, I'm going to put an image. I'm sorry, the object, right? Now, when we show you the example, we always start the object first and find the image. But you see all this example, right? This reverse engineer problem, why it would sometimes it would give you the image, right? Then you're gonna locate the object, right? Am I right?
Yes.
Yes.
Now I'm going to now I'm gonna draw it on the. Now I'm gonna put it here. Behind the sea, right? Now then I'm gonna do this drawing. Now the light coming in. But remember that I have a divergent lens, right? Hello? Or the concave lens, right?
Yep.
Then what happened to the reflecting wave? The reflecting wave will diverge. You got it?
Got it.
Yes.
but they look like they are coming out from the focal point on the same side, right? So what I'm saying is the wave will diverge, going out like this. It look like they are coming out from the focal point. I'm gonna draw the direction of the waves, right? Like this. You got it? Hello?
Yes.
Hello?
Yes.
Yes.
Got it.
Now then, what is second way I can do that? Second way I can do that is, remember that I'm gonna use my vertex. Here. Vertex just behave like a plain no lens, right? Or plain lens. Nothing reflect. Nothing deviated, right? And like this. Good. Hello? Hello?
Yes.
Yes,
Now, so
good.
therefore, what is
Yeah.
it? You see this two way? They never intersect, right? They're emerging out from the other side of the lens, right? But therefore, where's my location or my what is that? My image. So we reflect. I'm going back, right? So it should be here. Good. Hello.
Mhm.
Now, what can you tell about this? What can you tell about this image? Are they real or virtual? Are they real or virtual?
Virtual.
Is they real or virtual?
Virtual.
Virtual, right? Remember that for the lens, if your image is the same size of the object, they are virtual. And then are they enlarge or diminish? Diminish, right? Am I right? Hello?
Okay, it goes down.
They are smaller, right? Smaller. Smaller than the object, right? Is it right? Hello?
Yeah.
Now then, what else I can tell? They are erected, right? Am I right? Hello?
Yeah.
Yes.
Now this pretty much, if you draw another location, right? Let's say I'm gonna put my object here or here, then you will get the same result. It's just like the concave mirror, right? Or the divergent mirror. They always form the virtual, upright, and smaller image, right? So therefore, if you have a myopia, you have your glass on, whatever the thing you see there actually is smaller than the real size. Are you with me?
Yes.
Myopia means near sight, right? We're gonna talk about that later. Same meaning, right? This the term in the optometry, right? Good. Hello.
Good.
All right. Now I am going to now we can do a verification with the calculation, right? Now again, now let's say I'm going to DO. What is that? I was 6'6", let's say is 6'6", 20. Then what is F? F is look like 6, right? Right, good. It's negative, right? Why negative, right? Because see, we are using the focal point on the same side of the object, right? Good. Hello.
Yep. Yep, good.
Yes.
Now, I want to find the location of the image, right? So minus 1/6, minus 1/20, right? Am I right? Hello?
Yes.
What it is? There will be minus 20, minus 6, right? Am I right?
Yes.
There will be minus 20, 60 divided by 120, right? So therefore, what is the I? You have to flip them. What is this? 120 divided by 26. So 4.61. Now remember that my focal length is about 6 centimeter right here, negative. So is this minus 4.61? Right? The answer is yes. Right? Am I right? Hello?
Yeah.
Mhm.
Yes.
All right. Now I'm going to now the light parallel in. Now they're gonna diverge, right? Remember, I have a divergent lens, but divergent lens such that they're gonna what? When they diverge, it's going to oh, I'm sorry. So if I do this zooming outside the ruler, that's what happened. No, I'm zooming in first. Now when they diverge, and you have to reverse it back, you reverse the light back, right? But they're not only passing through the tips. You see my cursor moving here?
Yes.
So what I'm saying is this light will diverge. Oh, but we know that they're gonna never form that, right? They're gonna pass the tips of the image. Originally, they extend back to the intersect with the principal axis, right? So here will be my focal point. Right, make sense? Hello?
Yes.
Yes, it does.
Now then I can verify that by what? By drawing another line using the vertex, right? Now, by drawing another line using the vertex. Remember that the vertex, when you're passing through the vertex, right? They would just go straight, right? So like this. Hello?
Yes.
Now they this intersection here exactly. Yes, right? So what does really tell us that? Really tell us that my red line building is correct. Am I right? Hello?
Yes, correct.
Mhm.
Okay. Now, what else I can do? Now, I am going to give you a little bit of the next chapter. I'm looking at the book right here. Now, next chapter is all about the optical instrument, right? So again, all the basic physics principle we already learned it. But what we're gonna do, we're gonna put it what we learned in the chapter 25 in the context of chapter 26, right? So next chapter. All right, next chapter is about the vision and optical instrument. Right? Now, when I say vision, meanwhile, I'm talking about the eye, right? Am I right? Your eyes. And optical instrument, what we are talking about, we are talking about the microscope and the telescope, right? Telescope. Well, even the camera, right? Camera, you can think about it as a optical instrument. Am I right?
Yes.
Now, actually, a camera is a what is that? I should say that a camera using the principle of eyes. Right? Good. Hello.
Yes, good.
Now, eyes. Right? What does the eye look like? Right? Eyes look like this. Right here will be your eyeball. Right? So what is this? You're gonna have a lens inside here. Now the lens for the human inside, right? They are what kind of lens I have? They are convex lens, right? Good. Hello.
Yes.
Now then, what is this? And then you have a cornea here, right? Cornea. And then now this muscle, right? This two muscle here, they are control the thickness of the eyes. If the muscle contract, then the lens will be flatter. If the muscle extend, then the lens will be more thinner. You understand what I'm saying?
Yes.
Now
Yes.
this muscle, we call them a ciliary muscle. Ciliary. They call fiber, but they are really a muscle. And then what else I have? Now inside the cornea here, right? And they call the aqueous humor. Mean they are liquid or jelly type of the transparent material. Now what else I have? And inside the lens pocket here, right? They have the jelly type of the tissue, right? We call them a vitreal humor. Good. Hello. This is the lens. And then what else I have? Now then I have, now this part here will be my whole retina here. Good. Hello.
Good.
Now then you have the little bit thing here. That will be your iris, right? Right. If you have a European, the eye look like blue, right? The blue will be from here. You got it? Hello?
Got it.
Yes.
You can get a blue eye, right, by putting a contact lens through it. Now then I will connect it to the optical. That will be your optical nerves. And they have another name here, when part of the retina, right? They call the fovea. Fovea. It's just the name and the what they call that, the physiology, right? Okay, good. Now, it depends, right? Now, how the eye form the image, right? I can tell you that when the eyes form an image, now I'm drawing a simple version, right? Now I have an image here. And what happened? The image. Okay, I draw wrong. Okay, so I should basically, okay, let me draw another time. A simple drawing. Oops. Now, where's the image? The image will be here. Forming on the retina. Remember that the retina, you have all this, you have biology, right? Hello?
Mm-hmm.
The retina, you have all this called the cone and the rod cell, right? Am I right?
Yep.
Yes.
Now then your image will form here, right? Now, so therefore, whatever image is on your retina, they are upside down. You got it? Hello?
Yes.
Now, really depends on your disease, right? I mean the eye disease, right? So we call them a different way. Now we are generally we have 4 types of disease, right? You can collect that with the collecting lens. Now I'm gonna tell you this. 4 common eyes. Now I call them DC, right? It's, I mean, actually myopia is DC. You know that, right? Hello.
Mm-hmm.
Well, you can collect that with the corrected lens, well, different type of lens. Now the first thing is what? The first thing we call a myopia. Very common, right? Particularly, you have all this device, right? Your smartphone, your tablets, and you're watching the close-up distance for a long time, and then you're gonna strain your eye. You know what strain mean, right? You make your eye tired. Then your eye will, if you are in a certain age, right? Let's say from 14 to 25, if you're using a device too long, you're straining your eyes every day. What happened to your eye? The eye will grow longer, elongated. Hello?
Mm-hmm.
Mm-hmm. Now, believe it, if you're a normal size adult, right? The length here is, I think my optometrist told me that it's about 22 millimeters. Hello?
Yes.
Now, if you have the myopia, right? Another name of myopia is nearsight. Then what happened? Seeing your eyeball is elongated, right? So what happened is the image. Okay, I did not draw right. And the image is formed in front of the retina. Hello, you got it?
Yes.
Now, how are you going to correct them? The way you correct them, you're going to put a divergent lens. Good. Hello.
Yes, good.
Got it.
Now then, the path of the wave will change a little bit. It's hard to draw. They will diverge a little bit, and then converge again now. Good. Now then collect that such that the image will form approximately on the retina. All right, good. Hello.
Yes, good.
Now this is called a myopia, the near sight, right? Now then I have another problem, right? We call the hyperopia. Hyperopia, or the farsighted, right? We call them. The common term we use the one you understand it. Now, what is the hyperopia? Hyperopia is sometimes most of them they are genetic, right? Hello.
Yes.
Now I don't know whether you see some kid they wear many right undersized, so therefore you see his eyes very big, right? Why? The lens is nothing more than a convergent lens or the convex lens, right? Hello.
Mm-hmm.
Yes.
Now what happened to hyperopia, right? So I'm gonna go back to my. Well, when you have hyperopia, right, your eyeball is undersized. When you have an image here, and the object, right, I'm sorry, then the object is actually overshoot. Well, your image is forming behind the retina. You get it? Hello?
Yeah.
Yes.
Now, then how you gonna correct that, right? Then you're gonna put a convex lens, right, in front. So then you're gonna change the pathway of the light wave, right? Convert a little bit, and such that what? Such that you want to have your image collectively, approximately falling on the retina. Are you with me?
Yes.
Hello?
Yes.
Yes.
Now, then I have another type of the problem, right? We call the presbyopia. You know what's the Presbyterian, right? The church. Hello? Hello? Now, I don't know. The way I learned the Presbyterian, right? They translated to Chinese, right? It means old. You understand what I mean? So it really tells us that the Presbyterian is the part that the presbyopia is the problem for the old people or the elderly. Is it right? Hello?
Yep.
Yes.
Yes.
Yes. Now, what is the problem when you have a presbyopia, right? Presbyopia, right? So usually it happens after you're 40, right? Now, after you're 40, what happened? Then those muscle, right? Remember all those muscle we call what? We call the ciliary muscle, right? What happened to that, right? They lost the elasticity. So they're no longer able to control the focal point of your lens inside your eyes precisely. You understand what I'm saying? Hello?
Yes.
It's just like a rubber band, right? When the rubber band getting old, what happened? They no longer have those elasticity, or they become very brittle and they break, right? Am I right?
Mm-hmm.
So in this case, then presbyopia have the same optical deviation as the hyperopia, right? What does that mean? So mean that I have an object close up. So when you look at them, they are always forming behind the retina. The reason of that is you're no longer able to control you lost control of the lens. Now then how are you gonna correct them? The same idea, right? You're gonna put a convex lens in front, right? Hello? To replace those focal problem, right? The convex lens in front is relieve the focusing power of the human lens. You understand what I'm saying? Hello?
Yep.
So in principle, right? In principle, the hyperopia and the post-myopia, they're using same type of the lens to correct that problem, right? Now, by the way, all this problem, we call them reflected problem, right? Hello? So they are general name, but it's called a reflected problem. Reflected problem of your eyes, right? Okay. Now, what I'm gonna do, that's another type, right? Another type is called an astigmatism. You heard about that? Hello?
Yes.
Now, what is astigmatism, right? The problem of the astigmatism is caused by what? It's causing by your lens. No, I should say that your cornea, right? Now, astigmatism is caused by the cornea due to the imperfection. Or they are not a spherical shape, right? I should say that. You got it?
Got it.
Now, the way you correct the astigmatism, you're using different type of lens, right? They are rod-based, right? Now, I'm going to show you the last picture before we call off.